The biggest webinar on artificial intelligence in systems engineering. Are you ready?
Yeah, welcome everyone. We're so happy to see you here. Good afternoon to Europe, good morning to the US, and good evening to everyone from India and Asia. It's a pleasure having you here today in our webinar From AI Hype to Impact, How to Deliver Results Using AI in System Engineering. And I propose let's get right into it. Why are we doing systems engineering? We are doing systems engineering to create amazing products. But we feel in all industries, in all disciplines, there's a seismic shift, there's an earthquake coming, and it's called AI. So of course the question begs, can AI design and develop products for us? And here I'd like to say, that might be a bit early, a bit of an AI hype alarm. So in the next 30 to 40 minutes, we would like to explore this topic deeper together with you. We, that's me. My name is Robert. I'm one of the co-founders of Spicy SE. And joining me in the call today is my co-founder Torben, who will show you everything amazing live in the tool. And also in the chat, you will meet Sebastian, our CTO, who you can ask all these really deep and IT questions. Feel free to use the chat, use the question and answer function. And if hopefully in the next 45 minutes you see something you really like, talk to us. Scan the QR code in the lower left corner of your screen and book yourself a conversation with us. And with that being said, let's do it. Let's get into it. Well, the first question, why are we talking about AI? Why are we talking about AI now? And what's the hype? We see everywhere that there's pressure on basically all engineering industries by new and disruptive players, be it from the Far East, be it from new startups that are popping up left and right. And we're all focused now on speed, on looking after our resources, on cutting costs. We want to be agile. We want to iterate more quickly. And all of that while our systems are becoming more and more complex. We're going from products to systems to networks of systems and systems of systems and so on. And where does the hype originate? Well, as you just heard with our amazing cinematic intro that we just gave you, AI is producing just amazing results in our everyday lives, and we see that every day. However, what we also see is that sometimes it gets a bit confused here and there. Sometimes it hallucinates here and there. So the more important question is, can it produce or help us produce products in the quality that we need it to and that we are used to? So come on the journey with us and let's explore this topic in depth. Starting, of course, with our most important stakeholders, our customers, the people who buy the things that we produce. What do they care about? They want something of high quality, of high safety, at a reasonable, affordable price. So if I'm a company supplying these amazing products, what do I need to care about? Of course, also quality and price, but also time to market. I need to be quick. I need to be hopefully quicker than my competition with getting my amazing products out there. And what does that mean for me if I work in one of these companies, if I'm one of the human beings, the engineers, the minds inside this company, what do I think about? Well, also, we are responsible for the products that we push onto the world. So we need to think about quality and safety. Our products should do what they were designed to do, and of course, they should not do what they should not be doing. This is majorly important. But also, we have to acknowledge that every one of us is a human being, and we have our own targets and our own goals in mind. We want to do good work. We want to, have a career, step it up, and we're hoping that AI can help us do that as well. And in this room, I believe we have a lot of Mint people, a lot of engineering, a lot of math going on. Why did we study so much math? Because we want to have an impact on the world. We want to push innovation to the world. That's why we choose the careers that we're in the first place. And now in my company and humans, now we have a new player that's called AI. And the question is, what does AI want? And I'm happy to report, and we're recording this, so of today, the AI wants nothing. It's not conscious yet. We'll see, that could change next week, but for today, it's not conscious yet, so it has no intrinsic motivation. It has no moral and no rationale, so we should not let it directly develop our products. But how can we harness now the power of AI to make us faster and make us better? We go the indirect route. We use AI to make us faster, to alleviate us of all these tedious, repetitive tasks. We use AI to watch us and to give us advice and to give us guardrails and guidance when we need it, while keeping full responsibility for the output of our work. If AI can do that, that makes us reach our targets way better, way faster, and we bring innovation to the world way quicker. And now imagine if you have a company that's full of human beings who push innovation to the world at maximum pace. We make a lot of money. You all came here to see a presentation about AI today, and that will be happening, of course. But we first must talk about the ones who it's all angled around, which is our human beings that actually do the work, do the things, create these awesome products that we're talking about. So let's take a look at one of our engineers. And as you can see, she has a great idea in her mind at this point. She's thinking something very complex, and you can see how the idea is filling her whole brain bubble. And you can see on her face also she's concentrating very hard because it's a challenging and complex idea that she's thinking about. And this picture is enough to answer the most pressing question in systems engineering. And I'll give you 3 seconds to think about what the most pressing question in system engineering actually is. And yes, you're absolutely right. The most pressing question is, why do they always use PowerPoint? Why do we give them all the methodologies, processes, tools, trainings that they want, but they still deflect on us and they go away and they use Teams and email and Confluence and they put all their ideas everywhere else? Why? This picture explains it pretty well. Let's look back into the brain bubble of our engineer here. And we see that the idea is sharing the space with the amount of thought she has about the tools she's using. So is she going to use, to communicate, to publish, to discuss her idea, is she going to use her super complex SE tool that she went into a 2-week training earlier? No, she's not. And everyone who's in a system engineering, quality-oriented role, project manager role, you've all experienced this. Where do they go? What is the one tool that you can operate in your sleep, which takes up 0 of your brain bubble? It's PowerPoint. So that's the reason. Sounds trivial. It's the reason why people gravitate to putting their knowledge in PowerPoint. Now, why is that a bad thing? Because here comes the next guy, and he's super interested in that idea. And he's looking for knowledge about this idea, hoping to find it in our organization's single source of truth system. And he doesn't find it there, but he wants it. So what does he do next? He goes in and he calls a meeting. He goes in and he disturbs people and phone calls them, takes them off their concentration. And of course, that costs a lot of money. So the first point that I would like to drive home today in this webinar is actually not an AI point, but a human point. If you put something in the brain bubble of your people that's not innovation, you lose money immediately. Yeah, I'd like to repeat this. If you put something in the brain bubble of your people that's not innovation, you are losing money. And I know what you're thinking is like, oh, Robert, I feel you're right, but how can I quantify this? How can I go to my management? How can I convince them? How much could we save? I need a price tag. Well, we've got you, and we've created a return of invest calculator for systems engineering. And at the end of this webinar, so stick around, we'll share the link to it so you can try it out for yourself, play a bit around with the assumptions, and you will be as amazed as I am of how much time you could potentially save and how much money you could save if you save just a little time. It's really pretty impressive. And basically the results of this calculator is why we chose to create a new system engineering tool with a different approach. Spicy wants to be, or no, I retract that. Spicy is the systems engineering tool that takes up as little of your brain bubble as possible. And I already saw in the names that there's quite a few Spicy users here, but for everyone who has not seen or touched Spicy, I would like to hand over to Torben, who will give you just a quick look at the basic functionality of Spicy. Torben, please.
Thank you, Robert. Just a few minutes to show you very basic functionalities of Spicy SE. You should now see my browser. So Spicy is a browser-based tool, no installations, no updates, no version conflicts. For the user, that means just entering the website and start using Spicy. Below the address line, we see a menu bar with all the different features and functionalities of Spicy, and we are currently on the development tab. The development tab covers the left side of the V-cycle, and that's where we're going to stick on today. Of course, there are a lot more features in Spicy SE, but for today's webinar, we stay on the left side. So usually when we start developing something, we collect our stakeholder needs, and that's what we currently see in the top right of the window. We can create tabs to organize our requirements. So we have a base tab, for example. We can define risks.
Oh, sorry, Torben. There was just a message in the chat that people can't see anything. Is that happening to anyone else, or can you see it? Can you give a thumbs up if you can see it?
Okay.
Okay, Darshan. Then sorry, this seems to be a problem on your side.
Too small.
Too small.
I zoomed in a little bit, makes it a bit more ugly, but maybe that's better.
Yeah. Oh, now we see thumbs up and thumbs down. Thanks, now it's visible, he says.
Okay. Well, I zoomed in. As I said, it makes it a bit more ugly, but hopefully you can read and see it better now. So as I just mentioned, we have several different tabs where we can organize our requirements. I just jumped to one tab, which says obviously wrong link. There is a requirement in there which says the robot shall weigh a maximum of 150 kilograms. So let's see where it is linked later. Of course, we can create additional tabs for customer requirements, standards, regulation, and whatever. We will actually see that later. After we collected all our stakeholder needs, we want to define our context. And that's what we see in the bottom left, where we have our architecture view. And today we're looking at an urban delivery robot, which is our system of interest in orange here. It has interfaces to different systems in the world. So it's speaking to the environment. And the next thing we want to do is we actually want to specify our urban delivery robot as a black box. And this is a very fundamental basic of Spicy SE, that architecture and requirements are always shown together and attached to each other. So I can now select the urban delivery robot, and I will see the black box requirements towards the urban delivery robot. If I now want to link my requirements of the urban delivery robot, our system of interest, I can simply drag and drop this linkage icon in the right and drag it to the top. And you should now see highlighted where I can drop my link, which would mean the requirements are linked directly. And I can also do that the other way around. I can do it from the top to the bottom. In Spicy SE, that doesn't matter, because Spicy SE always knows the hierarchy of the system. It knows that the stakeholder requirements are on top and the system requirements are below. And that means the lower level requirements will satisfy the upper level requirements. The next thing we want to do after we described our urban delivery robot as a black box via requirements is we want to do white boxing. We want to do an architecture breakdown. To do so, I'm jumping into the architecture of the urban delivery robot by clicking on the level down button. And what you can actually see is that our system requirements now jumped to the top right, because based on these requirements, we will continue our development of the insights of the architecture. And in the bottom left, you still see the architecture and you can see the inside of the urban delivery robot. And you can probably guess it. I can now select any system boundary and it will show me its requirements in the bottom right. I can again link the requirements in the same way by linking them from the bottom to the top or from top to bottom. And that's pretty much it. I just needed like 3 minutes to explain you one of the basic fundamentals of Spicy SE, because now you could again dive into any of these architecture elements, break them down with the requirements, and so on and so forth. And that being said, I'm giving back to Robert to continue speaking about our features.
Thank you very much, Torben. And if you think that Torben made it look easy, there's no AI yet, it's coming. If you think Torben made it look easy and I will tell you that we make it easy, you shouldn't believe us, right? We're just madly in love with our own product. So don't take our word for it. Don't believe us, but maybe you can believe Sören, who is developing LiDAR sensors for autonomous driving, which means he's highly regulated and he's using Spicy quite successfully. Or believe Lydia, who's teaching the next generation of systems engineers at university. And of course, in teaching, right, she wants to focus on methodologies and system thinking. And she doesn't want to focus on where the buttons are. Or take Matteo, for example. He's building a thing. I can't tell you what it is, but he's building a thing from the ground up. So he's starting with a new idea at zero, and he is using Spicy for his development from day one. Very in contrast to Manuel, who I believe is in the meeting. Hey, Manuel, who has exactly the different problem. So he's heading a large organization with a lot of legacy, mature component development that is going to become one system. So he's trying to align and unify this diverse group of engineering. So all of these amazing humans are already using Spicy very successfully today. And that shall be the last of talking about humans. And let's get into the topic. We've already had someone impatient in the chat. Let's go to the topic that you've all been waiting for. Let's step into AI and what it can do for us. First, let's ask ourselves, what are we really bad at as humans? We're really bad at repetitive stuff. It's boring. We get frustrated. We get tired, right? So repetitive stuff, we're really not good. But we're really great at being creative. I mean, from just having an idea to putting people on the moon, humans have made it possible to think beyond and then manifest what they're doing. Is AI creative? I would say ish. Getting there, of course, but at the moment, I feel justified to color that box yellow. But it's really good at helping us with all these repetitive tasks because it doesn't get tired, right? It doesn't get frustrated. It doesn't have emotion. So, of course, you can see here where we want to go, what the premise is of AI development. We want to keep the creative with the humans and then aid with the repetitive and all the things that keep us from being creative using AI. And that will enable us to output the maximum of innovation. And now we go into the nitty-gritty. Now it gets real. We are going to show you real applications of AI, shining a light on different stages in a product development process. Starting out with finding stakeholder requirements contradictions. Then we'll take a look at traceability and how to speed that up. We're going to make sure that in any given system boundary, we consider all requirements when breaking that down further. We're going to inject some steroids into requirements breakdown. And then last but not least, and I'll be honest with you, we put this in just to brag, we'll show you some true magic when it comes to onboarding new team members to system engineering using Spicy SE. So let's get into it. Number one, stakeholder requirements contradictions. Why are they bad for us? Because in the best case, they will lead to discussions with our customer, meetings, and just like annoyance and frustration overall. In the worst case, they will lead to us having a redesign because we neglected to look into this ISO regulation or whatever we did. And a redesign always triggers a retest. In order to not having to do that, we have to cross-check all of our requirement specifications with our human brains. And what does that lead to? In the worst case, we're wasting millions and millions and millions with retests and redesigns. We are anyway wasting thousands of hours of manual labor, which is not innovative. It's frustrating for us. So we would like to get some help here. And to the rescue comes the requirement contradiction wizard, which is in Spicy SE. And Torben, show us what he does.
So as we have seen before, the stakeholder needs are collected in the top right, and we can have many tabs and we can have a lot of requirements in each of the tabs. So it's very easy to lose sight and overview of what and which requirements we have. And let me show you one example. So let's say our customer updates his requirements. So I'm creating a new tab for that. And we are going to import requirements from our customer into that tab. So I just loaded the CSV and our customer has a new ID. The delivery robot shall also carry people with a weight of up to 100 kilograms. Well, we were speaking about a delivery robot, so I'm not sure if that is a good idea. But let's take our contradiction with it, look at it. So there is this little icon, which is a magic wand. And here we have different wizards, and one of them is the contradiction wizard. And what the contradiction wizard does, it goes through all the tabs that we have, through all the requirements, and it compares them, and it checks if we have any contradictions within the requirements. And you can see it's loading. It's a live presentation, nothing pre-recorded. And the first contradiction it defined with a high confidence and a high criticality is this one. Requirement number 3 specifies the robot should carry packages up to 80 kilograms. That is actually our initial use case of our robot, right? While requirement 70, this is the newly imported requirement, states it should carry people up to 100 kilograms. These represent different payloads types with different weight limits, creating ambiguity about the robot's actual carrying capacity and primary purpose. So that makes sense, right? And it also shows us the requirements. We have already agreed to requirement number 3, and we have a new requirement number 70. And what does the AI suggest? We always give a suggestion here. It's always just suggestions by the AI. The final decision is with the human. Clarify whether the robot is designed for package delivery, people transport, or both. That's a good idea. So what we're going to do is we're going to change the requirement back to review. Also the other requirement, and we will clarify that with our customer next. And that's it, right? So now we have the requirements in review and we can talk to our customer. That being said, I'm giving back to Robert and he will talk about the next wizard.
Yeah, so traceability. We know that buzzword, we fear that buzzword. Why? Because we need to manually trace a lot of requirements. So we need to break it down from system to component, subcomponent, whatever levels we have. And why do we do it? We do it because we do not want to have an impact that we didn't see. Because, and you've guessed it, and you've seen it before, that will lead to redesign, retests, the millions wasted, the thousands of hours, and the frustration. So again, and you will find quite a recurring theme here, Spicy helps you out with yet another wizard. Torben, show us what the linkage wizard does for us.
All right. So we have now ensured that between all our stakeholder needs, there are no contradictions, right? The next thing we want to do is we want to ensure that all our stakeholder needs are covered by a system requirement. And we can already see some of these requirements are linked. Some of them are not. Of course, we could do that manually, and we will probably do that most of the time. But again, we have another wizard. And again, during the icon, I can access the link wizard. And what the link wizard does, it analyzes all the stakeholder needs, compares them to our system requirements, and will give us the information if we should add any links. So again, it's loading while we're talking. And let's hope it doesn't take too long. So first of all, let's take a look on the links that it's suggesting to add. So we have the stakeholder needs on the left, and we have the system requirements on the right. And let's take a look. So requirement number 3, I want the delivery robot to be capable of carrying packages up to 80 kilograms in weight. We already learned that was or used to be the main purpose of the robot. And we already have a system requirement. The urban delivery robot shall have package compartment for packages up to 80 kilograms. Well, makes sense. And if I like the suggestion, again, I take the final decision and I can directly accept the linkage here. And it's linking those two requirements. If I don't like the link at all, or I think it's a very bad suggestion, I can cross it out and the AI will not suggest this trace again. And also, very important, the AI will always give a rationale why it thinks this is a good idea. And I think in this case, it's very clear that parent and child requirements have exactly the same specifications. So let's look at another requirement. This, for example, the delivery robot operates in urban environments with varying pedestrian density and must avoid collisions. That's our stakeholder needs. And we have one system requirement which says the urban delivery robot shall have a collision avoidance functions which stop the robot in case of a collision risk. Sounds good to me, so I'm also accepting this link. It does not only suggest links to set, it also suggests if we have a wrong link. And if you remember, there was the requirement which said the robot shall weigh a maximum of 150 kilograms. This requirement is currently linked to the requirement in the system that the delivery robot must have a maximum speed of 10 kilometers per hour in pedestrian areas. Obviously, we don't want that link, so I'm unlinking here. All right. So now we have linked and unlinked requirements. And of course, we do not only link for the sense of linking, right? We want to do something with it. And you can now see one of the requirements I linked was requirement number 1. I linked it against requirement number 37. Requirement 1 already had some links, and I just added a new one. I can now select the requirement and switch to the linkage view in the bottom, in the top left. And in the linkage view, I can now follow my link throughout the complete system. So requirement 1 is my stakeholder need. I have now added the link to requirement number 37. And requirement number 37 itself is linked to several component requirements again. So perfect, we have now traceability throughout the system. And that being said, Robert.
Thank you, Torben, and thank you, Linkage Wizard, for giving me my time back, but leaving me in control. So the next step is looking at the requirements that are governing the system boundary we're currently thinking about and making sure that when we develop a component architecture, that we don't forget anything, that we consider everything. Why? And you can guess it. We don't want to have any missed impacts because of redesign, retest, millions hours frustration. You've seen this before. And another wizard is coming to the rescue. Torben, show us what the architecture wizard is doing for you.
All right, so now again, we have ensured no contradictions throughout the stakeholder needs, and we have all our stakeholder needs linked to a system requirement. And as mentioned, after we have collected all our system requirements and linked them to stakeholder needs, we want to ensure that our architecture is broken down. That's what we have seen already, and we have already created initial architecture. But how can we ensure that all system requirements are covered in the architecture? And I think there was a question that modeling is very important. So the next wizard can actually help us to ensure that our architecture model is complete. To use the architecture wizard, I click on the little gear icon and I have the architecture wizard. And again, what it does, it goes through all system requirements in this case, the top right requirements, which are the base for creating our architecture. It looks at the inputs and outputs, and it also looks at all the existing system boundaries in this level with their requirements. And now I will start the architecture wizard, and it will now suggest me architecture elements that I should add. And it also, again, as always, gives us a rationale why we should add something. So the first suggestion is a communication system. And why should we add a communication system? Because there was a requirement number 9, which states that the robot must maintain secure communication. And it also says there is no dedicated communication architecture element at the moment. And as I mentioned, just to clarify, there are also no requirements concerning this, right? So it does know that something is missing in the architecture and also in the requirements. Could be, of course, that in one of the other system boundaries, it is already hidden, not linked yet, but it knows better and tells us, please add a communication system. So I'm just adding the communication system now. I can place the communication system wherever I need it. I can connect it to other components like a battery pack to supply it with current or whatever it should now communicate with, and I can save it. And this way, I can now ensure that my architecture is complete in the end and all my system requirements are covered. Robert.
Thank you, Torben, and thank you, Architecture Wizard, as well. The next one, and almost the last one that we want to talk about today, is the requirements breakdown. So as you saw, Torben added a new component, and now probably the component responsible, who's not such a fan of writing requirements, most people aren't, is going to have to break down the system requirements, look what's in it for them, and then describe it on the level of their boundary box, of their component. And can you imagine your team being happy to do that? Are they excited about this? No, you know they're not. So manual requirements creation is a bit of a drag, and also here, it would be great if we could have some help. And why? Again, why do we do it? And I promise you it's the last time this comes up, but it's really important. We do not want to miss impacts. Impacts are expensive. If we design for something that we miss, or not design for something that we miss, that's really expensive with the redesigns and the retests and the millions that we can waste on this, the thousands of hours of either doing that or creating the requirements manually, and of course the frustration of our team. And you're probably guessing that I'm just going to show you one more wizard, but I'm not. We'll give you two more. Torben, give us requirement suggestion and proofing wizard.
All right, thank you, Robert. So, and again, we jumped a step from requirements to architecture. And of course, again, we want to define our requirements for our architecture components. So let's select one of the system boundaries, the cargo hold. And it is very common actually that not system engineers write requirements, but domain experts. And it might happen that they are not very trained on how to write requirements. And that's why we have our AI proofing. So for every single requirement, I can use our AI proofing. And the AI proofing will analyze the requirement and improve it. And I guess everyone here already saw it. There is a word that system engineers and requirements engineers hate. So let's see if our if our proofing finds that. And yes, you can see the first suggestion: replace must with shall to meet the requirement convention, and use a more precise term locking mechanism instead of just lock for clarity. So the AI makes the requirement much clearer and, of course, follows the conventions. Let's save that. Our requirement has now improved. Let's use it on another requirement, which is not as obviously wrong as the other one. So again, it's analyzing the requirement. The cargo hold shall have the capability to carry weights up to 80 kilogram. It's now computing suggestions. And what does it say? Use active voice and specify the product's action. Replace have capability to carry with. Yeah, sure. Let's use that. Shall support payloads weighing up to 80 gram. So it's a bit more specific, a bit more direct. And that's what we like, right? So let's save that as well. But of course, that's only like helping the requirements engineer writing requirements. But how do we ensure that there are no white spots within our system boundary description? And we can also do that, right? We see that there are already a bunch of requirements defined for our cargo hold. So the next thing I want to do is I want to find white spots. I right-click on the system boundary and it can suggest requirements for our system boundary. And again, it will analyze the system requirements. It will analyze the existing requirements within the system boundary, and it will see if anything is missing. So let the AI do its work. And in a second, we should have suggestions for our requirements. And there they are. And we can see the suggested requirements on the left. The cargo hold shall have an IP65 rating to protect internal components and packages from dust, ingress, and water jets from any direction. And why does it suggest to add that requirement? Because there is a system requirement the delivery robot shall have a weather-resistant design with IP65 rating. Sounds perfect, so I'm going to add it. And it will not only add the requirement, it will directly link it as well. And again, I could delete this suggestion if I don't like it, and it will give me a rationale why I should add that requirement. So I'm accepting that suggestion. And it does not only look at single requirements, sometimes it also combines several requirements into one, right? So we can go through the list and add all the requirements that the AI is suggesting, or of course not if we don't think it makes sense. We can not only use it, of course, to find white spots. As we just saw, we added a new architecture element, the communication system. This, of course, doesn't have any requirements yet, but if we want to get an initial idea of requirements that are needed for this component, I can again use the suggestion feature, and it will also add suggestions for a so far blank system boundary. So give it some time and it will compute suggestions for requirements within the communication system based on the system requirements of the urban delivery robot. And you can see it's suggesting quite a lot of requirements, again, based on several requirements, single or multiple. And we can decide which requirements we want to add. And if we add them, we have a great base to continue our requirements engineering work. And that was the last wizard. And now, Robert, back to you. Robert, you're muted.
Thank you. Yeah, that was the last wizard, but there is a meta wizard that combines all other wizards. So we at SpicySE, we're onboarding a lot of new people to systems engineering and especially onboarding them to SpicySE. And the problem that we face a lot is, we used to, don't do it anymore. We used to show them a coffee machine example, and they would politely nod and agree and follow along for the coffee machine, and then be like, well, yeah, it's nice for a coffee machine, but I'm building a nuclear fusion reactor, or I'm building a lawnmower, or I'm building an airplane. Like, for us, it's different. And I would like to kind of reflect on what Spicy is doing more in my area, in my industry. So now what we can do, and what we're going to show live, like also all the other demos, the AI was not pre-prepared. It was all live and it's going to stay live. We're going to build a product live in front of your eyes. And for that, we ask you, think of a product. It could either be from your past, from your present, or just from your insanely crazy imagination, and post it in the chat. You have probably 1, 2, 3 minutes to think about a product that you would like to see built, and then Torben and the Wizards will build it live for you. So think of ideas and then just put them in the chat. We're looking for really creative things. Egg boiler, already good. We'll wait for the next one. And while we do, we at Spicy would like to make you some offers, of course. Number one, we offer you to go and check out the Systems Engineering Return of Invest Calculator. This is really good if you're thinking, oh, I need to convince my management to get into SE. I need to convince my management to change our SE to something more lean. Then this is for you. Check it out, scan the QR code, play around with the numbers. And if you are amazed by the numbers as we are when we look at it, then also scan the QR code on the lower left and talk to us, and let's see what we can do for you. Now, summer's coming up, so we would like to offer you something to start. If your team size is about 10, 15 people, we made you a nice bundle that gives you licenses for 6 months and guided onboarding at a really reasonable price that you can communicate to whoever is budget responsible at your organization and get started super, super easy. If you want to talk, again, scan the QR code down on the lower left and talk to us. Of course, if you have a team smaller than 10 or larger than 15, also talk to us. We'll for sure find a bundle that suits you and that gets you into a lean, super fast, and AI-driven systems engineering way as quickly as possible. And now I'm done with all the advertising. Torben, did you select a product that we're going to build with our super wizard now?
Yes, I created 2 so far. Let me actually switch my screen. One was the autonomous driving baby stroller, which is created now. So here we have the autonomous baby stroller created. This is our system of interest, the autonomous baby stroller. And what it does, it creates a bunch of stakeholder requirements. It does create our system of interest with all its inputs and outputs. And it does create a bunch of system requirements. And from here on, again, of course, we could use all our wizards. So I could now jump into the system and use the AI to break down the architecture of the autonomous baby stroller based on system requirements. Secondly, I developed a self-lacing shoe system. That's what I got so far. So we have the self-lacing shoe system as a system of interest. We have the inputs, a user, a charging station, and a mobile app. And we have the outputs, walking surface, and the environment that we're walking on. And again, we have a bunch of stakeholder requirements and system requirements in the bottom. And again, of course, we could now jump into the system, break down the architecture based on the system requirements, and then define component requirements via the system requirements and the created architecture.
All right. So yeah, as you saw, basically what the super wizard has done is it's taken an idea, and basically the super wizard is triggering all other wizards and is taking the control that usually you have as a human. But this purple wizard is doing it for us, and then it can create very easily, it can create models that you can start with. Are these perfect? No, not at all. But are they fun? And are they a great way to get people in and get people excited about system engineering, which is something that I must say the system engineering community could do a lot better. So if you like, magic.spicese.com, we'll leave it up for about 3 more hours. So if you want to have fun after this webinar, go there, try it out, and enjoy how much fun systems engineering can be. And with that said, that's the end of it. We look forward to your questions, and hopefully we can provide some answers. So Samashwar asks, what about behavior? Yeah, unfortunately, we couldn't pack that into this webinar. Follow our updates. We'll have one on behavioral modeling for sure in the near future. And that's a good time for me to advertise the next one. Reusing system models made easy. So reuse, but in a spicy usability. For the last time, I swear it's the last time, scan another QR code and already sign up for the webinar so you don't miss any updates on this. And please, yeah, put your question in the chat and we'll try to answer them. If artifacts need to be generated and stored in config, is there a documentation wizard? I don't really understand that question, sorry. Is FMEA handbook supported? Well, you can take and export the things in Spicy that you need as a base for FMEA, but there are amazing FMEA tools out there. So for us, it was important to create the bridge, which we can do with our very nice and open GraphQL API. So you can take everything you need out of Spicy, sync it to your FMEA tool, and then go from there. Which LLM does it use? This is a great question. We have a backup slide for that. So there's 3 possibilities that you can use. First one is you trust the SOC 2 certification that major LLM suppliers will show that they have. That makes it very easy. That's what we do because we don't have to care about IP at the moment. So we can just send it to Claude or wherever we want. The second is take a proprietary LLM and run it on Amazon Bedrock. Or the third one is run a proprietary LLM like Qwen, or I think the big whale is DeepSeek, and run it on your local machines. That's the most secure one. So there's many different options to keep your data secure. What else? What is the tech stack for AI? book a call and discuss with Sebastian. He loves discussing about this. Do we have an architecture methodology like Arcadia? I love this question. It comes up a lot. And the answer is ish. Our goal, our main focus is to integrate everyone into systems engineering, especially the people who are at the moment skeptical about systems engineering. And that's the people who will never open up a book and read a methodology. The people who read about methodology are the people who are interested in systems engineering anyways. We don't have to win them. They're already won. So we do have an architecture methodology, but it's so interwoven into the tool that you can execute the methodology just by using the tool. So we simplify the methodology to a level that you don't even need to learn what that is. Does that make sense? I hope. I see that you have a review tool built into Spicy. Does your AI integrate with this? Kind of, yeah. You run the proofing tool, you see what you can improve, and then you give your agree statement. You can also have checklists that will give you the question that you want to ask to your requirements. So kind of yes, I would say. Do we support variant handling on Spicy? Klaus, please take out your phone, scan the QR code, and come to the next webinar. Pranod, can I ask Spicy to refer to a specific regulatory document? Yes, 100%. Preferably, you would take that document and make it into a recif format, so you have linkable requirements, and then import the recif to Spicy, and then really link the requirements out of that document rather than just referring to a single document. Link to try Magic out. It's just magic.spicy-se.com. magic.spicy-se.com. Oh yeah, Sivas already put it in the chat. Would you call this model-based systems engineering? Yes, 100%. We have a model and we do systems engineering with it. I would say 100% yes. Is the onboarding wizard creative, can generate delighters, or does it produce only satisfiers? Nice question. Try it out. We made the perfect society and all kinds of craziness with it. So your imagination is the limit to what Magic Wizard can do. Alan asks, can you import huge records from legacy systems? That's kind of a two-way question. One, is it technically possible? Yes. Two, should you? No. The cool thing about Spicy, and you saw Torben navigating the system architecture and these cascading system boundaries, the cool thing is that you can actually cut the requirements into digestible bits for all of your people. If you have, and if I read the word huge, it reads to me, maybe I read it wrong, that it's not quite usable for your people, it's not attractive for your people. So you should take the opportunity and slice it and allocate it to system boundaries and make it easier for your people, right? Again, the whole goal of Spicy SE is to make systems engineering be the transdisciplinary discipline that it's set out to be. Alexandros asks, can I import system architectures? Yes, and we will also have a webinar on that very soon. Yeah, check for updates. Check for updates. We'll show that live at some point as well. All right, that's the chat. You can also just raise your hand or just speak as well. That's also no problem.
No, I think I've switched off that you're allowed to activate your voice.
Sorry. So you can't speak. Can you simulate anything? At the moment, out of the box in Spicy, no. The reason for that being, again, is that there are amazing simulation tools out there. The thing that we felt we needed to produce a tool for is the interdisciplinary communication. In our firsthand experience, and also what we get reflected from customers and people we speak about systems engineering, it's the connection of all the disciplines. That's where we don't really have an approach and a tool. That always seems to fail. That being said, simulation is really covered and there's amazing tools for it. So again, I refer to a really cool, very open API where we can just connect tools to it and link all of these tools. Alan says, great presentation. Thank you. That makes our day. Is there, oh yeah, nice question, Himan. Is there an option to set up in-house server instead of web-based? Yes, 100%, especially if you're in defense or some other highly security relevant area. This is what you want to do. And of course, we make that possible for you, no problem. Scan the QR code in the lower left corner and let's talk. William, do we interface with tasking, for example, Jira? Yes, we have an out-of-the-box Jira coupling via API. This is a request that customers of ours have had, so we built it. So that's actually very easy. This is already out of the box. It seems this tool is also getting complex. How are you going to handle this? Asked Akif. Well, it has more functionality now. You're right, but you don't need to use it if it's too complex for you. It's very hidden. So you can go through the main V still with the same spicy simplicity that we've had from day one. Hopefully, if you saw something that you didn't like, Akif, we're looking forward for your feedback. Alexander, are we pursuing accreditation in defense organizations? We're actually running a POC with a defense company. Accreditation, yeah, that's in the future. Lucian Popa asks, is Spicy externally certified for automotive safety use, or is it planned to be certified soon? We did a gap analysis on this, so we're perfectly capable of gaining that certification. That being said, we don't have it yet, but we're planning on getting it soon. Jasmine, thank you for the appealing presentation, and the presentation very exciting. Thank you very much, Jasmine. It was lovely to have you here. Is the backend tool system L-based? No, it's not. It's an SQL library with our proprietary, but very easily understandable data model. Stefan says, awesome, great session. You guys rock. Thank you, Stefan. You rock too. Thank you for being a Spicy Power user. And Victor says, great session. Cool. We have 3 more minutes. So if there's any questions you want to ask here, please do. If you're satisfied, please, or if you have 1,000 questions, again, QR code down in the lower left-hand corner. Book yourself a slot. We'd love to hear from you. Thank you, Sören. Enjoy your time with your new baby. Do you think I could replace Codebeamer instance with Spicy? Says Jesus. Of course. How can I say no to that? You should, actually. Today. Dinesh asks, when can we get the recording of the session and how? To be honest, we don't know that yet. We'll let you know, Dinesh, as soon as we know. Thank you, Thomas. I would like to have an easy dashboard created that everyone sees the current status and progress over time. Jürgen, we have that. We just didn't have the time to show that today. So Jürgen, if you're interested, and you've asked a lot of good questions today, lower left-hand corner, scan the QR code, and we'll show you some more cool stuff that's in Spicy. Thank you, Craig. Stephen, is Spicy SE fully web-based? Spicy is browser-based to your end user to make it easy and accessible to them. You can run Spicy on-premise at home on your own servers if you like. Thank you, Paolo. Thank you very much for coming in today. Yeah, well, I have the time. Scan directly the QR code for the next one, 13th of June, 2 o'clock CET. We hope this is a time that's quite fitting for everyone, America, Europe, Asia, that everyone can come in. Yeah, thank you, Stephen. Yeah, browser-based is key because your users don't have to do any installation or maintenance. So it's very, very easy. Thank you, Lucian. Thank you, Sameshwar. Gelly, I hope I pronounced that correctly. You can export the model out of the box into PDF for documentation and stuff. But also you can use the AI to give you XML or similar formats, and then scramble them to what you need. So basically, the API is super open. Everything you can do manually, you can do with the API, and then take it to where we need to go. Thank you very much, Tom. Thank you very much, Vincent. Thank you, Ali. Really cool of you to come, to take the time for us. Thank you. Thank you so much. All right, it's 59. This is your last chance for a question, and then we will close the line, but let you know very soon where the recording is. Oh, cool. We see applause and fireworks. Thank you so much. Thank you so much for the love. That's really nice. Thank you all for coming. Can you import project data from Polarian or Enterprise Architect? Yes, 100%. When it comes to requirements, we can import recif, so that's really easy, straightforward. When it comes to modeling, either there's an export into another language, but also, and we will show that in a webinar that's very soon to come, using AI, you can also even do screenshot to Spicy as a proof of concept we did, so also that works. Nowadays, using AI, the tool back and forth is actually not going to be so much of a problem anymore as it used to be. Thank you for your question, Ivan. Thank you, Daniel. And yeah, this will be the last of it. We got done on time. Thank you all so much. And we will close the line now. See you on 13th of June. Bye-bye.
Bye-bye, everyone.